New space telescope could spot potentially hazardous asteroids heading for Earth. A new space telescope that could spot potentially hazardous asteroids and comets heading for Earth is one step closer to reality. The Near-Earth Object Surveyor Space Telescope, or NEO-Surveyor, has been approved by NASA to move forward to the design phase. The 20-foot-long, 6-meter-long, infrared telescope would bolster planetary defense by helping astronomers find asteroids and comets that come within 30 million miles, 48 million kilometers, of Earth's orbit. The mission's launch is currently scheduled for the first half of 2026. NEO-Surveyor will have the capability to rapidly accelerate the rate at which NASA is able to discover asteroids and comets that could pose a hazard to the Earth, and it is being designed to discover 90% of asteroids 140 meters, 459 feet, in size or larger within a decade of being launched, said Mike Kelly, NEO-Surveyor program scientist at NASA headquarters, in a statement. Wednesday is International Asteroid Day, commemorating the Earth's largest recorded asteroid impact while focusing on the real danger of asteroids that could collide with Earth. In 1908, a powerful asteroid struck the Podkomnaya Tunguska River in a remote Siberian forest of Russia. The event leveled trees and destroyed forests across 770 square miles, which is equal to the size of 3/4 of the U.S. state of Rhode Island. The impact threw people to the ground in a town 40 miles away. And it explains why astronomers and the Asteroid Day group want people to be aware. Detecting the threat of near-Earth objects, or NEOs, that could potentially cause grave harm is a primary focus of NASA and other space organizations around the world. In 2010, NASA completed its goal of discovering 90% of all near-Earth objects larger than 1,000 meters, 3,280 feet, in size. The agency was then directed by the National Aeronautics and Space Administration Act of 2005 to find 90% of NEOs larger than 140 meters, 459 feet. To date, NASA has found 40% of the objects within this range. Each night, astronomers across the globe diligently use ground-based optical telescopes to discover new NEOs, characterize their shape and size, and confirm they do not pose a threat to us, said Kelly Fast, program manager for NASA's NEO Observations program, in a statement. Those telescopes are only able to look for NEOs in the night sky. NEO-Surveyor would allow observations to continue day and night, specifically targeting regions where NEOs that could pose a hazard might be found and accelerating the progress toward the congressional goal. This illustration depicts NEO-Surveyor, a new mission that could discover most of the potentially hazardous asteroids that are near Earth. The ability to discover and characterize potentially hazardous NEOs also allows astronomers to track these objects. Currently, there are no known NEO impact threats to Earth for the next century. However, unknown NEOs can lead to unpredicted impacts, like the Chelyabinsk event in Russia. In 2013, an asteroid entered Earth's atmosphere over Chelyabinsk, Russia. It exploded in the air, releasing 20 to 30 times more energy than that of the first atomic bombs, generating brightness greater than the sun, exuding heat, damaging more than 7,000 buildings and injuring more than 1,000 people. The shockwave broke windows 58 miles away. It went undetected because the asteroid came from the same direction and path as the sun. The NEO-Surveyor will use infrared sensors that can help astronomers find these objects, even ones that may approach Earth during the day from the direction of the sun. This isn't something that's possible using ground-based observatories. By searching for NEOs closer to the direction of the sun, NEO-Surveyor would help astronomers discover impact hazards that could approach Earth from the daytime sky, said Amy Mainzer, principal investigator for NEO-Surveyor at the University of Arizona and professor in the University of Arizona's Lunar and Planetary Laboratory, in a statement. We think there are about 25,000 NEOs large enough to wipe out an area like Southern California, Mainzer said. Once they get bigger than about 450 feet, 137 meters, in diameter, they can cause severe regional damage. We want to find these, and as many smaller ones as possible. The NEO-Surveyor can search for asteroids by sensing the heat they emit in infrared light. This information can help astronomers detect the position, movement and size of NEOs. The telescope will follow an orbit that takes it outside of the Moon. This position will allow it to scan the sky and focus on areas near the Sun where asteroids with orbits that bring them close to Earth can be found. Sign up for CNN's Wonder Theory Science newsletter. Explore the universe with news on fascinating discoveries, scientific advancements, and more. Earth-approaching asteroids and comets are warmed by the sun, and they give off heat that the NEO Surveyor mission will be able to pick up, Mainzer said. Even asteroids as dark as a chunk of coal won't be able to hide from our infrared eyes. With NEO Surveyor, we want to spot potentially hazardous NEOs when they're years to decades away from possible impact. The whole idea is to provide as much time as possible to develop mitigation efforts that enable us to push them out of the way. Deflecting asteroids. If there is enough warning, near-Earth objects could possibly be deflected. Later this year, NASA will test its asteroid deflection technology to see how it impacts the motion of a near-Earth asteroid in space with DART, or the Double Asteroid Redirection Test Mission. 2 decades ago, a binary system involving a near-Earth asteroid was found to have a moon orbiting it, dubbed Didymos. In Greek, Didymos means twin, which was used to describe how the larger asteroid, which is nearly half a mile, 805 meters, across, is orbited by a smaller moon that is 525 feet, 160 meters, in diameter called Dimorphos, which means two forms. In late 2022, Didymos and Dimorphos will be relatively close to Earth and within 6,835,083 miles, 11 million kilometers, of our planet, the perfect time for the DART mission to occur. The DART spacecraft will deliberately crash into Dimorphos to change the asteroid's motion in space, according to NASA. This collision will be recorded by LISHACube, a companion CubeSat or Cube satellite provided by the Italian Space Agency. The CubeSat will travel on DART and then be deployed from it prior to impact so it can record what happens. A few years after the impact, the European Space Agency's HERA mission will conduct a follow-up investigation of Didymos and Dimorphos. This fast impact will only change Dimorphos' speed as it orbits Didymos by 1%, which doesn't sound like a lot, but it will change the Moon's orbital period by several minutes. That change, which is unlikely to be a negative one, can be observed and measured from ground-based telescopes on Earth. It will also be the first time humans have altered the dynamics of a solar system body in a measurable way, according to the European Space Agency.